22% brightness surge in a single second, then nothing. A silence so sharp it felt like the universe withholding an answer. And now, observer, you've arrived at the moment this mystery finally opens. Some say chance brought you here. But what are the odds truly that an object from another star drifts past Mars on a 1 in 20,000 trajectory, brushing a world whose soil is just beginning to speak again? What if that brief pulse of light was not a warning, but the beginning of an exchange? What if Mars changed because something touched it in the dark? Stay a while, traveller. Let's drift through the quiet together. The first clues did not arrive with drama. They came as faint numbers inside long columns of data, the kind that drift across the screens of patient researchers late at night. Hydrogen cyanide appearing in a thin whisper above Mars. Nickel in the soil where iron should have been. Values small enough to dismiss, yet aligned with a precision that left no natural path to explanation. In the quiet of laboratories, this is how change begins, not with shock, but with a tilt in the pattern, a soft deviation from the expected curve. Tonight, the universe whispers again. Mars has always been a world of stillness, a place shaped by winds that shift dust but leave chemistry unchanged for ages. Its surface rests under a thin sky, its minerals unhurried, its reactions slow, like the fading pulse of a world that cooled long ago. For 50 years, orbiters and rovers traced that stillness. Instrument after instrument confirmed the same truth: Mars was quiet, chemically stable, predictable in a way comforting to scientists who prefer order to surprise. Yet the numbers arriving in late October carried a tone no instrument had voiced before. The Trace Gas Orbiter was the first to notice the anomaly. It detected a spectral signature that did not belong to the usual family of Martian gases. A narrow line, hydrogen cyanide, subtle but unmistakable. It appeared only in certain regions, as though carried by a thin breeze that refused to distribute it evenly. Hydrogen cyanide is reactive fragile under ultraviolet light and easily broken by water. Mars does not offer protection for such molecules. Yet there it was, lingering in pockets of cold air. Silence is the language of distant worlds, and in that silence the molecule held its shape a little longer than it should have. Maven confirmed the finding days later. The spacecraft, designed to read the upper atmosphere of Mars like a weathered manuscript, observed the same molecule ionized and shimmering faintly against the solar wind. Independent readings seldom aligned so neatly, yet these did. Not a storm, not a volcanic trace, not an instrument error, but something carried in the dust, something energized by sunlight, something unfamiliar. When numbers repeat themselves across independent systems, the universe is offering a lesson. Whether we understand it or not depends on patience more than certainty. Down on the surface, curiosity went on with its slow ritual, sampling soil heating grains, reading the spectra of tiny minerals. For years, the rover had seen the familiar signatures of Martian dust, basalt fragments, trace metals, occasional meteor residue. But in November, a measurement arrived that felt out of place. Nickel in concentrations 3 times higher than its baseline. Not strange in itself. Nickel visits Mars often through cosmic debris. But this nickel carried no iron, not even a faint companion peak. On Earth, these elements travel together, born from the same stellar furnaces. To find one without the other is to find a story with missing pages. The rover repeated its test, as all careful explorers do. The same result returned. Nickel pure and crystalline, resting quietly in the fine dust that blankets Gale Crater. The grains were small, unusually uniform, as though shaped not by random breaks, but by evaporation or slow condensation. Their surfaces carried traces of carbon compounds subtle enough to miss unless one was looking for them. Chemistry rarely creates such order on its own without heat guiding it or energy shaping it. To see it on Mars was to feel the subtle weight of an unanswered question. Up in orbit, researchers traced the timeline backward. 2 weeks earlier, Mars had crossed the outer haze of the interstellar traveller we call 3-Eye Atlas. Not a collision, nothing dramatic. Simply 2 paths crossing in the geometry of space. A planet moving at 24 kilometers per second, and a visitor casting off dust gas and ionized metals shaped by a history older than our Sun. Planets do not remain untouched when they pass through a memory like that. Even a thin brush of particles can settle filter and react in ways too subtle for eyes, but not too subtle for instruments. The dust that settled onto Mars was not typical cosmic dust. Its spectrum carried spikes of nickel without iron, carbon, compounds in unusual ratios and cyanide signals too strong to fit the familiar profile of solar system comets. Every element has a story written in its bonds. The story of this dust belonged to a different star, a different chemistry, a different silence. Listening to it required reverence more than certainty. As researchers reconstructed the encounter, a gentle realization began to take shape. Mars did not change on its own. It changed because new reactants had entered a long quiet system. Hydrogen cyanide found pockets of cold air where it could rest. Nickel settled into the soil where sunlight and thin winds could reach it. None of this was violent. It was simply the universe doing what it has always done, letting matter meet matter, letting energy find paths it had never taken before. If you look at a planet for long enough, you expect stillness. But stillness is often a story we tell ourselves, not a property of worlds. Mars reminded us that even the quietest places can shift when touched by something ancient. And you, traveller, are here at the moment when that shift becomes visible. Somewhere beyond our reach, something ancient still moves. And tonight the stars keep their silence as Mars rewrites a small part of its chemistry grain by grain, molecule by molecule. It's all right to not know. The cosmos remembers for us. Mars moves through space with a steady patience, following an orbit older than anything humanity remembers. Nothing about that path suggests disruption. The planet traces the same ellipse circles, the same sun turns under the same faint winds. Yet in early October, Mars drifted through a region of space no model had ever marked as special. A thin stream of interstellar dust, quiet as distant rain, crossed its trajectory. No alarm sounded, no cameras captured the moment, but chemistry remembers what eyes forget. The coma of 3I Atlas stretched millions of kilometers, diffused gentle, almost transparent. To a spacecraft, it would have looked like sunlight passing through a fine mist. To a planet moving at 24 kilometers per second, it was contact with material shaped by a history that did not belong to our solar system. The dust did not arrive as a wave. It simply settled across the atmosphere grain by grain, carried by motions too subtle to map. Sometimes the universe changes a world not through impact, but through breath. As the dust entered the Martian atmosphere, something quiet unfolded. The smaller grains slowed, warming in the thin air before sinking. The larger ones sailed on untouched. Mars does not stop cosmic particles. It softens them. Its atmosphere, though fragile, is enough to give wandering molecules a moment of pause. This is atmospheric capture, a process as old as planets themselves. Earth does it too, though we rarely think about the origins of the dust we sweep from our windowsills. What made this dust different was not its movement, but its memory. Spectroscopic studies of 3I Atlas had shown a composition almost unfamiliar nickel, without its usual partner, cyanide in unusual abundance carbon compounds that flickered through wavelengths, unlike the signatures catalogued from local comets. Every grain was a fragment of a distant place, a record of processes shaped by a star we have never seen. When this material entered Mars' skies, it was not the dust of our system returning home. It was a visitor whispering an unfamiliar chemistry. The dust eventually settled into new patterns across the surface. Some gathered in basins where the cold air lay heavy. Some drifted into craters where morning sunlight would later touch them. Some remained suspended for days, held by the delicate balance of Martian winds. And it was here in this calm drift that the first quiet reactions began. Not complex ones, not dramatic ones, simply the meeting of molecules that would not otherwise have met. Hydrogen cyanide lingered in the lower atmosphere longer than it should have, nestled in temperature inversions that form when night gives way to day. The thin Martian sky allowed starlight to move through it, with little scattering leaving the gas untouched except by the rising sun. Cyanide is fragile, yet here it found a rhythm between darkness and light. Some of it interacted with dust grains carrying metallic surfaces. Some of it descended slowly toward the ground. Science often seeks grand events, but but sometimes meaning lies in persistence rather than spectacle. In the soil, nickel settled among particles of ancient basalt. Under most conditions, it would have remained unremarkable, just another metal resting in silence. But the nickel carried by 3 Atlas bore a structure shaped by heat and vapour processes not native to Mars. Its crystalline form reflected temperatures and pressures foreign to the red planet. These grains, tiny and polished by long travel, did not behave like common meteor dust. They absorbed heat differently. They interacted with carbon differently. They weighted differently. Many researchers expected the anomaly to fade. Dust storms could have buried the grains. Ultraviolet radiation could have broken down the cyanide. Winds could have scattered the chemistry beyond detection. But the signals remained measurable. The numbers repeated themselves with the soft insistence of something that had settled into equilibrium rather than decay. Listener, sometimes the cosmos chooses subtlety over display, and in that subtlety, truths settle gently into place. Scientists traced maps of deposition zones, their models following the quiet arc of Mars through the tail of 3I Atlas. The patterns matched with an elegance that surprised even those accustomed to orbital mathematics. Regions with elevated cyanide overlapped with regions of unusual dust density. Nickel concentrations aligned with predicted paths of grain capture. The planet did not receive this material randomly. It received it according to geometry, the same geometry that shapes tides, moonlight, and the slow spirals of galaxies. To walk across the Martian surface during those days would have been to see nothing different. The sky the same, the dust the same, the quiet as deep as before. But beneath that stillness, molecules rearranged themselves in ways that did not fit the geologic timeline. Some reactions began at dawn, paused at dusk, and resumed under the cold glow of starlight. Others held their shape between cycles, waiting for heat that would come months later. A world can appear unchanged long after its chemistry has begun to shift. As more data arrived, a new understanding formed, not one of alarm but of humility. Mars was teaching something simple. Even small additions to a quiet system can create new pathways. Chemistry responds to opportunity the way light responds to gravity, following paths set not by intention, but by possibility. What happened on Mars was not an event, but a meeting between a planet cooled into stillness and the remnants of a traveller older than its deserts. Somewhere beyond our reach, something ancient still moves, and Mars, touched briefly by its passing, holds a trace of that journey in its dust. The planet has not awakened, it has not transformed. It has simply opened a quiet door, a chemical threshold crossed gently, almost kindly. Tonight the stars will keep their silence. It is all right to not know the full story yet. When the first analyses from the rovers were compiled, the numbers rested on screens like quiet footprints. Nothing shouted, nothing contradicted itself, but something was gently out of place, like a familiar melody shifted by a single note. Mars had always been a world where chemistry followed slow, patient cycles. Metals weathered into oxides, dust settled into thin layers, molecules endured long seasons without disturbance. Yet now the readings suggested activity small, focused, precise. Curiosity's measurements revealed nickel in concentrations that did not match the planet's geologic memory. It was not the presence of the metal that puzzled researchers, but its purity. Metallic, crystalline, lacking the iron that should have travelled beside it. On Earth, this form appears only through controlled processes, temperatures adjusted, with care gases introduced in correct proportions, materials allowed to evaporate and settle in orderly symmetry. But on Mars, no furnace waited beneath the soil, only cold landscapes shaped by long ages of wind. The rover repeated its tests with the patience for which machines are known. Every sequence returned the same answer: pure nickel, in particles so fine they seemed sculpted by evaporation rather than broken by force. The grains did not point to violence but to transformation. Dust shaken loose from the tail of 3 Atlas could explain the origin but not the structure. Somewhere in its journey, the material had been shaped by conditions no Martian environment could reproduce. In this way, the particles became messengers, not of intent, but of history. Hydrogen cyanide added a second voice to the quiet puzzle. The molecule had been detected in the lower atmosphere where sunlight and cold air met each morning. It appeared not as a global haze, but in small persistent concentrations, as though carried by gentle currents instead of storms. Cyanide is reactive, eager to bind, eager to break apart, yet here it lingered long enough for multiple instruments to confirm it. A molecule so fragile should have faded. Instead, it drifted through the Martian dawn like a thought that refused to dissolve. Mars was not producing these molecules. That much became clear with time. Nor were they relics of an ancient epoch. They belonged to the dust and gases shed by an interstellar traveller, shaped in a different cradle of formation. Each molecule carried the temperature of its past, the pressure of its origin, the quiet endurance of a journey across light years. And Mars received them not as threat, but as presence. Silence is the language of distant worlds, and this silence held chemistry unfamiliar to ours. Researchers traced the correlations between the nickel on the ground and the cyanide in the air. They found patterns. Regions touched by denser dust showed stronger chemical signatures. Areas predicted to have passed through the centre of the debris stream aligned with increased anomalies. The data flowed into soft curves that mirrored orbital models. No chaos, no contradiction, just a new arrangement of matter settling quietly on a patient world. Mars had not changed overnight. No transformation unfolded with heat or force. Instead, the surface gained new ingredients, each capable of participating in reactions previously impossible. The planet remained still, yet within that stillness potential formed. Molecules met under low pressures and cold temperatures. Dust grains absorbed light differently than native minerals. Surfaces that once hosted only iron oxides now held metals able to lower the energy needed for reactions to begin. These were not reactions of life or complexity. They were simply new paths, gentle, understated, waiting. The beauty of chemistry lies not in its immediacy, but in its patience. A catalyst does not force a reaction, it invites one. Nickel, especially in its pure form, is such an invitation. It allows carbon molecules to rearrange with less resistance. It nudges hydrogen into new bonds. It offers possibilities without dictating outcomes. And on Mars, after the passing of 3I Atlas, such invitations settled across landscapes untouched for eons. Dust that once behaved only as dust now carried the quiet ability to guide reactions that had never taken place there before. Some wondered whether these reactions mattered, whether they represented anything more than academic curiosity. But the answer lay not in the scale of the reactions, but in their novelty. For the first time in modern observation, Mars was hosting chemistry it did not originate, not directed, not engineered, simply inherited from the long arc of a comet's journey. And in this inheritance, the planet gained a story we'd not anticipated, a reminder that worlds are not closed systems. They breathe in the dust of passing travellers the way oceans absorb starlight. To scientists, the data brought both clarity and humility. Clarity in that the measurements were consistent, replicable, and grounded in physical processes. Humility in that the source of the processes lay far beyond our familiar models. Most comets follow predictable compositions: water ice, simple carbon molecules, a scattering of metals. But 3I Atlas carried something different: chemistry, shaped by a star whose heat we have never felt, whose light falls nowhere near our telescopes, whose planets, if any, follow rhythms unknown to us. Mars became a canvas for that distant chemistry, holding its traces like faint strokes across a red desert. Nothing dramatic unfolded, no plume, no colour shift, no visible mark. Yet the measurements formed a quiet chorus: new molecules, new metals, new interactions, all gentle, all small, but all real. And for those who study planets' reality, no matter how subtle, is enough. Tonight the universe whispers again. The dust of a distant world rests on the surface of Mars, patient and unhurried. No one knows yet what paths these molecules will take or whether they will fade with time, but the uncertainty carries no weight of fear, only the reminder that even familiar planets can still surprise us, and even quasit chemistry can tell ancient stories. Sleep traveller, the cosmos remembers. When Mars moved through the diffuse trail of 3I Atlas, nothing dramatic announced the encounter. Space does not reveal its moments the way weather does on Earth. There is no sound to mark transition, no shimmer to reveal crossing. A planet simply continues along its path, steady and ancient, while invisible particles drift across its thin sky. Yet this quiet passage carried significance not through force, but through inheritance. The comet's tail was not a dense plume, but a long stretched veil, more like the faintest smoke than matter. And yet even the faintest veil can leave traces when a world drifts through it at orbital speed. Mars met the trail gently, its atmosphere absorbing part of it, its gravity pulling another portion downward. Most particles sailed onward into the deep dark, but a few hundredths of a percent remained. That fraction was enough to begin a new conversation between matter and time. Mars does not cling to dust in the way Earth does. Its winds can raise particles but cannot keep them aloft indefinitely. Once the grains entered the atmosphere, they spiral downward through thin layers of cold air, settling according to weight and shape. The cyanide molecules behave differently, too light to fall quickly, too reactive to remain unchanged, too fragile to persist without pockets of shelter. Yet somehow they did persist, gathering softly in low-lying regions where temperature inversions held them for longer than expected. As the dust settled, the planet accumulated what could be called a memory material, shaped by a star that burned elsewhere under conditions Mars would never know. This idea, though poetic, rests on scientific truth. Every atom holds the history of the forces that shaped it. Every grain of dust is an archive of forming heat decay or radiation. When Mars absorbed the remnants of 3 Atlas, it absorbed experiences not its own. A world can change quietly simply by receiving what another world once knew. The interaction that followed was slow, almost meditative. Nickel grains rested on basaltic sand, waiting for sunlight to warm them. Cyanide molecules drifted through cold dawns like small wandering shadows. Carbon compounds hovered between breakdown and endurance. None of this chemistry rushed. None of it demanded change. The reactions that took place were small and sparse, but they were undeniably new. A newness on a planet that had known stillness for geological ages carries its own quiet weight. Many researchers compared the phenomenon to walking through a mist. When you step through a fog on Earth, most of it passes around you. A little clings to your skin, a little settles on your clothes. Mars did the same, but on a planetary scale. The comet did not alter the world by impact. It brushed against it. It decorated the atmosphere with unfamiliar molecules. It shifted the baseline of what reactions were possible. In this way, even a soft encounter between worlds becomes meaningful. What moved scientists most was the precision in timing. 2 weeks after the planet crossed the debris field, the anomalies appeared. Not before, not long after. Exactly within the window predicted by models of particle settling. Like soft echoes returning from a distant call, the signals arrived in sequence: first cyanide in the atmosphere, then nickel in the soil. Data does not always align with such elegance. When it does, the universe seems to be offering a gentle reminder that patterns exist even in silence. The strange part was not that Mars received dust. It has been receiving dust for billions of years from comets, asteroids, and interplanetary drift. What set this event apart was the chemistry of the dust itself. Nickel without iron suggests a refining process or an origin environment where temperatures and pressures separate elements differently than in our solar system. Cyanide in unusual abundance suggests carbon-nitrogen chains formed under a different balance of heat and radiation. These signatures do not imply purpose, they imply diversity across cosmic landscapes. Listener, it is easy to forget that our solar system is only one version of how matter can arrange itself. Other stars forge elements in different proportions. Other nebulae cool at different rates. Other comets gather dust under temperatures our models rarely explore. When an interstellar object enters our system, it brings with it those distant conditions like faint perfume carried on a returning traveller's coat. Mars simply encountered a scent that did not belong to its familiar desert. The questions that followed were not urgent, only contemplative. What happens when unfamiliar materials settle onto a familiar world? How does a planet respond when offered chemistry shaped elsewhere? Could these traces fade? Could they combine? Or would they remain as small whispers recorded in dusty craters for centuries? Theories formed, but none demanded haste. The planet itself moved slowly, and so did the science. Every measurement that arrived felt like part of a larger unfolding calm. The anomalies were real, but not alarming. The reactions were present, but not forceful. It was as though Mars had paused briefly in its ancient stillness to consider what had touched it. A planet cannot think, but chemistry can reflect in its own way the quiet meeting of histories. As researchers continued to compare data from orbiters and rovers, one truth grew clearer: Mars had not been harmed. It had simply been written upon with a different ink. Dust from a distant star lay scattered across its plains. Molecules from a long interstellar journey wandered through its cold air. The planet held these new elements without resistance, the way sand holds footprints until the wind decides otherwise. Somewhere beyond our reach, something ancient still moves. And Mars, brushed by its passage, carries a small part of that movement now. There is no urgency in this story, only chemistry, finding new paths, dust finding new homes, and a world accepting what arrives on its winds. Tonight the stars will keep their silence. It's all right to not know where this path leads next. Long before any rover detected anomalies on the surface, the first signs of change drifted high above Mars in air thin enough to barely hold warmth. The atmosphere of the red planet is delicate, almost hesitant, a faint envelope of carbon dioxide and dust that surrenders heat each night and gathers it again each dawn. Most days it behaves like an old clock, predictable, measured and steady. But after Mars passed through the trail of 3 Atlas, the clock gained a new rhythm, subtle but present, like a breath drawn a little differently. Hydrogen cyanide appeared first, not as a blanket spread across the world, but as quiet clusters suspended in the lower atmosphere. The trace gas orbiter detected them almost accidentally while scanning for seasonal changes in methane. The molecule showed itself as a thin signature in the infrared spectrum, a narrow line that researchers at first suspected was interference. But repeated measurements confirmed it. Cyanide drifting through cold Martian air is something like a whisper carried in fog, a soundless presence lingering longer than expected. What puzzled scientists was not that the molecule existed, cosmic dust can carry precursors, but that it maintained concentration long enough to be detected from orbit. On Earth, hydrogen cyanide breaks down easily. On Mars, with its thin air and relentless sunlight, it should fade even faster. And yet, it did not. It rested in pockets of still air, as though held gently by the planet's own slow rotation. Silence is the language of distant worlds, and this molecule moved within that silence with unexpected grace. As the cyanide lingered, Mars' atmospheric cycles continued their ancient pattern. Daylight warmed the surface, sending light winds drifting across plains and craters. At night, temperatures fell sharply, creating layers of cold air where molecules could pause before being carried onward. The cyanide remained suspended between these movements, too light to settle quickly, too reactive to vanish immediately. It became part of the atmosphere's daily rhythm, a small addition to a cycle unchanged for ages. Meanwhile, dust from 3I Atlas continued its descent. The smallest grains hovered for days before finally joining the surface. The larger grains fell swiftly, guided by gravity alone. Some of these particles acted as platforms where stray molecules, cyanide among them, could rest temporarily. When sunlight struck these grains, subtle surface reactions occurred, not enough to alter the world, but enough to remind scientists that even dust carries possibility. Chemistry does not need applause to begin its work. It moves quietly through whatever paths physics allows. As orbiters mapped concentrations of atmospheric gases, MAVEN contributed additional clues. It detected ionized traces in the upper atmosphere, suggesting that some molecules carried more energy than expected. Whether the energy came from solar radiation or from interactions with particles in the comet's tail was difficult to determine. But the presence of ionization indicated participation in a new kind of atmospheric behavior. No storms, no turbulence, only soft interactions that shifted the balance of certain regions. These observations sparked a gentle realization among researchers: Mars had become a temporary archive of interstellar chemistry. not through force or transformation, but through the simple act of hosting molecules shaped elsewhere. When a planet receives dust from beyond its system, it becomes part of a story older than itself, and that story does not disrupt the world. It accompanies it like a quiet companion walking beside a river. Some scientists modelled how long these foreign molecules might remain before breaking apart. The answers varied. Hydrogen cyanide might persist for days in cold air pockets, for weeks if bound to dust, for months if shielded by shadows cast by crater walls. None of these timescales were dramatic, yet all were long enough to allow brief chemical meetings interactions that Mars had never offered before. And in the quiet interplay of these molecules, the atmosphere took on a slight new character. Still thin, still ancient, but touched by something transient. As the cyanide drifted and the nickel settled, attention returned to the broader picture. Mars's atmosphere had not changed fundamentally. It had not thickened, warmed, or gained complexity. Instead, it held a new presence, small and delicate, that moved with the planet's own calm. Each molecule traced arcs shaped by gravity, temperature, and light. Each grain of dust followed a slow descent shaped by winds that barely stirred. Through these movements, Mars revealed how naturally it can host the unfamiliar without resisting. For planetary scientists, the beauty of this moment lay not in the anomaly itself, but in its precision. The timing matched the models of deposition. The distribution matched the paths predicted by orbital mechanics. The signals matched the chemistry detected from Through-Eye Atlas. Even in silence, the universe reveals structure. The planet was not reacting randomly. It was responding exactly as physics would predict when a world meets dust from a distant star. In this way, Mars became a reminder that interactions between planets and comets are not always explosive. Most are gentle, carried out through thin atmospheres and slow deposits of matter. These encounters leave no craters, no visible scars, only molecules resting where they were not before. And to those who watch the cosmos closely, such moments carry their own quiet wonder. Traveller, when you look toward Mars, understand that its stillness is not emptiness. Worlds hold their stories in layers of dust and air, in small deviations from long, established rhythms, in the chemistry that lingers for a season before fading back into silence. Tonight, the stars will keep their calm. It's all right to not know where these molecules will drift next. On the surface of Mars, change unfolds in a rhythm so slow that even centuries feel brief. Rocks weather grain by grain. Dust shapes dunes not through storms, but through repeated whispers of wind. The chemistry of the ground has remained nearly untouched for millions of years, each mineral holding the memory of an ancient ocean or volcanic burst that happened long before humanity began to watch the skies. Yet now, within this long quiet, the planet receives something small but new dust, whose journey began around another star. When those grains settled, they blended with Martian soil as though they belonged. Nothing marked their arrival. No shift in colour, no warmth in the ground. Only instruments could sense the difference, reading spectral lines that spoke in soft codes of origin and temperature. Nickel in pure metallic form appeared among the powdered basalt. It rested like a faint note added to a composition that had not changed in epochs. Mars itself offered no resistance. A world does not choose what it inherits. It simply receives. Curiosity's spectrometers studied these grains with patient attention. Light reflected off their surfaces in ways unlike native particles. Mars usually hosts metals bound within oxides, weathered, muted, softened by time. But the nickel that arrived carried a sharper signature, a crystalline clarity that hinted at vapor formation rather than fracture. Such formation requires heat cycles or pressures that Mars has not known for ages. Whatever shaped this metal did so far away under conditions the rover could only measure but never fully imagine. Some grains held carbon compounds on their surfaces, thin traces of chemistry carried across interstellar space. These compounds were not complex. They were not biological. They were simply remnants of a chemical environment shaped by another sun. To researchers, they represented not anomalies but stories. Every molecule is a quiet record of the place that formed it. And here among Martian sands, those stories settled without ceremony. The planet's stillness offered these new arrivals something unusual time. Mars lacks the quick rains and active geology of Earth. Its reactions unfold under low pressure and extreme cold. In such a setting, even small interactions progress slowly, like thoughts drifting toward clarity. The nickel grains began interacting with carbon present in the dust. The cyanide molecules that found their way to the surface rested near metallic surfaces that subtly altered their energy thresholds. None of this happened fast, but all of it happened gently. As scientists examined the data, they realized that the planet was not reacting dramatically, only expanding the range of reactions possible upon its surface. In a system stable for millions of years, even a small expansion feels like a quiet awakening. The chemistry of Mars had not become active in a biological sense. It had simply become open to combinations it had not offered before. Dust and stone met under colder skies, guided by the same laws that shape galaxies and oceans. Chemistry does not need life to create pattern, it only needs opportunity. Regions exposed to sunlight behave differently from those in shadow. Warmth encouraged certain reactions, nudging molecules toward new arrangements. In colder areas, reactions paused, preserving intermediates that would normally break down. Mars became a patchwork of microenvironments, each responding differently to the presence of these new materials. Nothing rushed. The planet offered space for possibilities to unfold in their own time. From orbit, the changes were invisible. Even from the surface, a human observer would see nothing but red dust and muted horizons. But in the instrument's silent records, subtle shifts accumulated. Ratios changed, spectral lines strengthened. The soil's chemical signature gained a faint accent, as though a new voice had joined a long-held conversation among minerals. The beauty of science lies not only in answers, but in the quiet recognition that the universe often speaks softly. The nickel and cyanide found on Mars were not messages, only matter. Yet their presence carried meaning, because they opened a reminder that planets do not exist in isolation. They cross paths with travelers older than themselves, and sometimes those travelers leave small gifts behind. Scientists traced the movement of dust across the landscape. They followed wind models, mapped slopes, and accounted for sunlight angles to predict whether new chemistry might continue to accumulate. Some regions would see the molecules fade quickly, others sheltered by geography or shadow would preserve them longer. Mars does not distribute its mysteries evenly. In the stillness of these quiet plains, the planet absorbed its encounter with interstellar memory. The reactions taking place now would not lead to sudden transformation. They would lead instead to subtle possibilities, potential pathways waiting for energy, waiting for time, waiting for conditions not yet determined. And that patience aligns perfectly with the nature of Mars. It has always moved at the pace of eternity. Listener, when you think of this world, do not imagine sudden change. Think instead of dust settling on stone of molecules resting in cold air of chemistry, unfolding with the calm of a planet that carries its history without hurry. The encounter with 3I Atlas did not wake Mars. It simply reminded us that even quiet worlds continue to receive the universe grain by grain, across ages we barely comprehend. Tonight the stars will keep their silence, and the dust will find its place upon the planet as it always has. It's all right to not know what paths these grains will take in years to come. When sunlight reaches Mars, it arrives without the softness filtered through Earth's thick sky. It strikes the surface directly, warming rock and dust in sharp contrasts of light and cold. Each sunrise lifts temperatures just enough to nudge molecules into motion, and each sunset draws that warmth away again with equal swiftness. These cycles have shaped the planet for billions of years, carving its chemistry into predictable patterns. But after Mars inherited dust from 3I Atlas, the daily rhythm of heating and cooling gained new meaning. Pure metallic nickel responds to heat differently than the iron-rich particles common on Mars. Even a slight rise in temperature allows its crystalline surfaces to interact with surrounding molecules more readily. During the first mornings after the comet's passage, these grains absorbed sunlight and reached energies that nudged carbon-bearing molecules into motion. Nothing dramatic occurred. No plumes, no colours, no visible trace. But in the quiet interior of dust grains, bonds loosened and reformed with an ease they had never known on this world. This is the subtle language of heat invitations rather than commands. Hydrogen cyanide, still drifting in thin clusters across the lower atmosphere, behave differently under sunlight as well. The molecule is fragile, but in the cold Martian dawn it lingers in a delicate balance. As the planet warmed, some of these molecules descended gently to the surface, carried by thin downdrafts, as predictable as the shadows of crater rims. When they reached the nickel grains, they rested briefly before moving on, leaving faint traces of interaction behind. Chemistry of this kind does not reshape a world. It simply adds nuance to its silence. As researchers studied these interactions through remote data, they began to realize that Mars offered a perfect stage for slow chemistry. Its cold air preserves intermediates. Its low pressure encourages reactions to proceed without turbulence. Its steady cycles of heating and cooling offer gentle pulses of energy rather than violent bursts. If Earth is a symphony of rapid reactions, Mars is a single sustained note extending across ages. The arrival of interstellar dust added a quiet harmony to that note, not louder, only different. During midday, as the ground warmed further, certain carbon compounds began adhering more firmly to metallic surfaces. They did not form complex chains. They did not behave as precursors to anything biological. They simply arranged themselves in patterned layers that reflected the conditions of their arrival. These layers were thin enough to evade sight, but thick enough to appear in spectral readings. Scientists often describe reactions in terms of activation energy thresholds and kinetics. But here on Mars, reactions felt more like slow gestures than thresholds crossed. As the sun dipped below the horizon, temperatures fell rapidly. Mars loses heat the way a stone cools in open air directly without protection. During these nights, reactions paused. Molecules rested in whatever arrangements the day had offered, waiting for the next sunrise. This stop-and-start rhythm created a slow choreography across the surface, a cycle of rearrangement and stillness that repeated with the planet's rotation. Chemistry, when given time and low pressure, forms patterns not through speed but through patience. Scientists tracked how these cycles influenced deposition. Nickel grains collected more carbon residue in regions with high sunlight exposure. Cyanide traces clustered near areas where cold air settled at night. In sheltered basins, patterns persisted longer. On open plains, they faded quickly. A world shaped by wind became a world shaped by heat, at least for a season. Patterns did not require intention to form, only the gentle nudges of temperature and time. The team studying these changes approached the data not with urgency, but with curiosity. The findings did not threaten missions or require intervention. They simply illuminated how Mars responds when touched by matter carrying an unfamiliar history. Every measurement emphasized the same truth: the planet remained stable. Its chemistry remained sparse. But within that sparsity there was room for new pairs, small possibilities unfolding without hurry. Heat cycles influence more than molecules, they influence texture. Some regions developed thin coatings of altered dust, neither unique nor transformative, but different enough for instruments to notice. These coatings reflected light at slightly shifted angles. They created faint, localized variations in thermal emission. To the naked eye, the planet remained unchanged, but to spectrometers and thermal imagers, Mars now carried a whisper of a different chemistry, like a faint accent spoken by a world usually content in silence. In their reports, researchers described the phenomenon with gentle precision. They spoke of surface energetics, adsorption dynamics, thermal desorption of cyanide-bearing compounds. Yet beneath these terms lay something simpler. Mars was quietly accommodating what it had been given. The planet did not resist the foreign dust, nor did it transform dramatically because of it. It simply absorbed the material into its ancient routines of warming and cooling. In that calm continuity, the science became almost lyrical. Some wondered how long the effects would last. The answer varied with geography. In bright equatorial regions, reactions would fade in weeks. In shadowed craters, they might persist for months. On polar plains, perhaps even longer. Mars distributes time unevenly, offering longevity to some environments and fleeting cycles to others. But the presence of these reactions, however brief, reminded scientists that planetary chemistry is never truly closed. It is influenced by every grain of dust and every photon of sunlight. Traveller, the story unfolding on Mars is not one of upheaval. It is one of breath and warmth of molecules drifting toward the possibilities that light permits. The planet has accepted its encounter with 3i Atlas the way a stone accepts morning frost quietly without resistance. And now, as we observe these small changes from afar, we are reminded that the universe shapes worlds not only through collisions and storms, but also through the gentlest touches of dust and heat. Tonight the stars will keep their silence, and Mars resting beneath them will continue its calm conversation with the chemistry it now holds. It's alright to not know what faint patterns tomorrow's sunrise may reveal. Mars is a world shaped by patience. Its rocks endure ages, its winds sculpt plains grain by grain. Its chemistry, sparse and unhurried, moves with a rhythm that mirrors the slow turning of the planet itself. After the passing of 3i Atlas, this ancient rhythm gained a new softness, not as disruption, but as quiet possibility. Dust from beyond the sun settled into surface layers, and the planet responded with its usual measured calm. Nickel grains that had fallen across the plains began to take part in the planet's daily cycle. When the morning sun warmed the ground, a faint interaction unfolded between metal and air. Carbon-bearing molecules softened against metallic surfaces, arranging themselves into thin films shaped by the energy of daylight. These films were not complex. They lacked structure beyond simple layering. But their presence signaled a new story within Mars' long silent geology, the meeting of matter shaped by two different stars. As daylight strengthened, certain dust-coated regions absorbed heat more efficiently. Instruments detected gentle alterations in thermal behavior variations too small for human senses, but real enough to register as deviations from the long-established temperature curves. These regions cooled differently at dusk, releasing their warmth with new pacing. Such shifts held no danger and no urgency. They simply reflected the delicate influence of foreign grains woven into native soil. At times, cyanide-bearing molecules settled near these warmed locations, resting like faint shadows before drifting into the air again. Mars's thin atmosphere allowed such molecules to hover at the edge of dissolution, neither fully stable nor fully lost. Sunlight broke some apart. Cold preserved others. The balance formed a quiet interplay between surface and sky, like the slow turning of a page in a book written across millions of years. Scientists studying these behaviors understood that nothing here pointed toward transformation. There was no spark, no chain reaction, no awakening. Instead, they saw chemistry, exploring the margins of possibility. The presence of pure nickel allowed certain reactions to begin at lower energy thresholds. The presence of cyanide gave carbon-nitrogen pathways a chance to form momentary arrangements before dissipating again. These were not steps toward complexity. They were simply reflections of the universe's tendency to test every path available. On Earth, chemical pathways unfold quickly. Water accelerates reactions. Dense air encourages collisions. Biological systems add catalysts beyond anything geology alone could offer. Mars, by contrast, extends every process. Its dryness and thin atmosphere create long pauses. Its cold nights preserve intermediates like frozen thoughts. Where Earth's chemistry rushes, Mars drifts. And into this drifting system, the dust of 3i Atlas brought new ingredients that behaved according to the same slow pace. Some days the nickel grains hosted tiny films of carbon that thickened by only a few molecules. Other days the films vanished with warming winds. No two cycles were identical. Yet over time, patterns emerged, where sunlight struck at particular angles, or where terrain sheltered grains from the wind interactions lasted longer. The planet became a mosaic of tiny laboratories, each shaped by geography, temperature, and the heritage of interstellar dust. Maven and the Trace Gas Orbiter continued watching, collecting data like soft echoes returned from the planet. Atmospheric readings showed faint decreases in cyanide over time consistent with slow breakdown. Surface readings, however, suggested a temporary absorption of fragments into dust layers. Neither trend pointed toward permanence. Mars was not being rewritten. It was simply hosting a story for a while, a guest in the form of unfamiliar chemistry carried from afar. Even these small findings reminded researchers of something fundamental: space is never empty. Worlds influence each other through fields, particles, and chance alignments. Over millions of years, planets cross paths with debris from countless origins. Most encounters leave nothing behind, but occasionally, as with 3i Atlas, a trace remains long enough to observe. That trace is not a warning. It is an invitation to reflect on how matter travels, how stars shape elements, and how those elements move across the quiet distances between systems. During colder seasons on Mars, reactions slowed even further. Dust remained still in shadowed hollows. Nickel grains cooled into a near-frozen calm. Cyanide molecules retreated into thin air layers, drifting with almost no energy. The surface chemistry paused, holding its potential like a breath between thoughts. In these pauses, the planet's silence felt especially deep, as if it were reflecting on the gentle encounter it had experienced. Of course, planets do not reflect, but chemistry can linger in ways that feel contemplative. Across all observations, one truth remained steady: Mars was stable. Its soil remained familiar, its air remained thin. The new chemistry, while intriguing, never threatened the balance of the world. Instead, it reminded scientists that discovery is often quiet unfolding not through dramatic events, but through subtle measurements at the edges of perception. Listener science lives in these edges where patience reveals what haste might overlook. The dust from 3 Atlas will fade, winds will bury some grains, radiation will break apart fragile molecules, time will return the soil to its usual sparse reactions. But the moment of encounter, the quiet drift of interstellar matter meeting a cold world, will remain recorded in the memory of instruments in the files stored on distant servers and in the imagination of those who watch the skies with steady devotion. The universe moves slowly, but it always moves. Tonight the stars will keep their silence, and Mars, carrying a small echo of a star not its own, will continue to turn beneath them unchanged in its stillness, yet gently reminded of the dust that once crossed its path. It's all right to not know what small possibilities tomorrow may bring. As the weeks passed after the encounter with 3i Atlas, Mars settled back into its familiar quiet. Winds resumed their slow reshaping of dunes. Frost formed at dawn along crater rims. Dust drifted in gentle spirals across plains older than any memory life has known. Yet the chemistry beneath this quiet carried faint new possibilities, subtle, temporary but real enough to remind scientists that even ancient worlds continue to learn from what touches them. The nickel grains from the interstellar visitor remained scattered across the surface, small and shimmering under certain angles of light. Although invisible to human eyes, instruments caught their reflections, noting how they warmed slightly faster than native particles. With each sunlight cycle, these grains offered tiny bursts of energy to nearby molecules, nudging them toward rearrangements too small to matter on a planetary scale, yet meaningful as hints of a planet's evolving canvas. Hydrogen cyanide, meanwhile, thinned gradually from the atmosphere. Its concentration declined not abruptly, but in a slow taper, following patterns consistent with natural decay. Some molecules drifted into cold basins protected by shadow for a little longer. Others broke apart under ultraviolet light. A few settled into dust, engaging in brief interactions before releasing their fragments back into the thin air. Every path was gentle. Nothing hinted at escalation, only the quiet dispersal of a molecule not meant to last long under these skies. Scientists approached the data with care, tracing correlations between dust deposition, surface temperature, and atmospheric composition. Their models revealed something elegant. Mars had responded exactly as physics predicted. Nothing unexpected emerged beyond the initial anomaly, but within this predictability lay the story itself, a world that had absorbed a small echo of another star's chemistry and allowed it to settle into silence without disturbance. Some regions of the planet displayed slightly altered thermal behavior, likely due to faint coatings of carbon-rich residues. These coatings absorbed light in patterns different from native dust, creating micro-variations that oscillated with each sunrise and sunset. To a spacecraft, these shifts appeared as tiny deviations in infrared readings barely above noise levels, yet consistent enough to matter. Small things often teach us more than grand ones. In these slight variations, scientists glimpsed the delicate interplay between foreign matter and an ancient landscape. Curiosity's continued soil sampling revealed that the nickel grains persisted in fine dust layers, Carried across short distances by winds that flowed down crater walls like slow-moving rivers, the grains did not clump or transform, they simply drifted with the terrain responding to topography, light and seasonal air currents. Mars, with its thin atmosphere, moves dust almost thoughtfully, never in haste, always in rhythm with the planet's rotation. In areas where dust settled thicker, short-lived combinations between metal and carbon appeared more frequently. These interactions remained simple adsorption of molecules onto metallic surfaces, faint reorganizations prompted by sunlight, and slow nighttime cooling that preserved transient arrangements. No reaction grew beyond its environment. The chemistry stayed close to the ground, like a whisper that rises only to settle again. To geologists, this behavior aligned with their understanding of Mars as a world that evolves not through rapid change, but through quiet accumulation. A dune shifts by centimeters each year. A rock fractures across millennia. Chemistry follows that same pace. The new reactions introduced by the interstellar dust fit seamlessly into this logic. They were new, but they belong to the planet's natural tempo, a tempo that feels almost meditative in its consistency. As atmospheric cyanide continued to fade, researchers noted something gentle. The molecule had left no lasting imprint on Mars's sky. No new reactions spiraled outward. No compounds accumulated beyond expected levels. The atmosphere simply breathed it in and exhaled it back into silence. Listener, this is often how distant worlds respond to change, not through upheaval, but through absorption and release. A molecule arrives, lingers for a moment, and then joins the vast quiet again. This understanding brought scientists to a deeper reflection. The encounter with 3i Atlas did not transform Mars. It enriched our awareness of how worlds interact. Planets do not exist in isolation. They cross paths with comets that carry the chemical signatures of long-travelled histories. They gather dust shaped under alien temperatures. They receive fragments of distant memories and incorporate them with a patience that defies urgency. And through these encounters we learn more about both the visitor and the world it brushes against. Models predicting the behaviour of the nickel grains suggested they would eventually bury themselves within deeper dust layers. Over time, ultraviolet radiation would soften their surfaces. Winds would grind them finer. Whether they remain detectable decades from now is uncertain. Yet uncertainty here is peaceful, not troubling. A planet holds what it holds for as long as physics allows. Nothing more, nothing less. Traveller, consider this: Mars has spent billions of years refining itself through stillness. Even the arrival of dust from another star becomes part of that stillness. The planet accepts what touches it without urgency, allowing possibilities to unfold at a rate governed only by time and temperature. This is not the story of transformation. It is the story of a world quietly listening to the universe. Tonight the stars will keep their silence. Mars will continue its slow turning beneath them, carrying the faint trace of an interstellar traveller across its plains, not as disruption, but as a soft reminder that even quiet worlds remain connected to the drifting chemistry of the cosmos. It's all right to not know where those grains will rest next. In the months following Mars' passage through the trail of 3i Atlas, the planet settled into a new equilibrium so gentle that even sensitive instruments recorded its changes only as faint lines in graphs. Nothing visibly shifted on the plains. No colour blossomed across the soil. The sky remained the familiar pale red that has touched the horizon for ages. Yet within the fine grains of dust and the thin layers of the atmosphere, quiet traces of the encounter persisted like a soft memory carried across seasons. Thermal patterns across the surface displayed small localized variations, subtle differences in how sunlight warmed certain regions and how quickly they released their heat into the night. These deviations aligned with areas where nickel-rich dust had concentrated. Pure nickel absorbs and disperses energy differently than native Martian minerals, and that difference, though slight, contributed to a new rhythm in the landscape's daily breath. Heat lingered a little longer in some places. It faded sooner in others. For a planet that measures change in geological epochs, even these minute shifts are part of its ongoing story. As researchers continued to study data from Curiosity MEVN and the Trace Gas Orbiter, they found confirmation of the same calm truth, the chemistry introduced by 3i Atlas. remained delicate, patient, and contained. Hydrogen cyanide slowly reduced to fragments, leaving behind no lasting reaction beyond its gentle contact with metallic grains. Nickel particles continued to drift in the dust, thinly spread across plains and crater slopes. None of these components acted with urgency. They simply followed the laws that govern all matter, responding to light pressure and time. The beauty of these findings lay in their restraint. Many imagined that an interstellar visitor might bring dramatic change, yet what unfolded was far more consistent with the quiet tendencies of the cosmos. When worlds meet the remnants of distant stars, they do not erupt, they absorb. They hold fragments of the encounter the way a desert holds impressions of passing wind, subtly, almost imperceptibly, but with meaning for those who look closely. Mars in its long stillness responded in exactly this way. It offered no resistance to the foreign dust. It did not amplify its reactions. It simply allowed the new chemistry to settle into place as naturally as grains of sand shifting between day and night. The planet's thin atmosphere continued its cycle of slow breathing, rising gently with heat, and falling again into cold. Cyanide that once drifted in low pockets of air faded into memory with each new dawn. Dust carried by local winds gradually covered or relocated nickel-rich grains, tucking them into deeper layers of the soil. Across all these calm processes, the presence of interstellar material remained detectable only through careful observation. Instruments registered small repeating variations, differences in spectral lines, slight elevations in trace compounds, faint thermal deviations. These subtle signals formed a tapestry of evidence that Mars had hosted the chemistry of a world beyond our Sun. Not dramatically, not permanently, but meaningfully in the way that even a quiet breath can shift the atmosphere around it. Scientists studying these changes found themselves speaking less of anomalies and more of relationships. A planet's chemistry is not static. It exists in conversation with space open to dust radiation and the gentle influences of passing travellers. Mars had simply participated in such a conversation, accepting what drifted toward it without disturbance. This understanding deepened the appreciation for planetary environments as living records of cosmic motion, each holding fragments of encounters scattered across time. Some of the nickel grains, still unoxidized and bright in their crystalline structure, reflected the harsh midday sun in unusual ways. If one could stand beside them, the difference would be imperceptible. But to orbiters watching from afar, the grains created tiny glints, subtle anomalies in reflected light that shifted with angles and seasons. These small signatures served as a gentle reminder that matter retains the memory of its origin even when resting on foreign soil. Other grains moved with the wind into sheltered hollows where temperature swings were less extreme. Their surface reactions slowed further, preserving interstellar chemistry in a kind of suspended calm. In these places, Mars held on to the encounter a little longer, the way quiet valleys on Earth preserve snow long after hillsides have melted. Worlds have their own ways of remembering, and those ways unfold without haste. As time continued, models predicted that winds and dust storms would gradually bury the grains deeper beneath the surface. Once covered, the foreign material would enter the slow, geological clock of Mars, perhaps resting for centuries before resurfacing through erosion. This long view of planetary memory brought comfort rather than concern. Mars would continue to evolve as it always has, molecule by molecule, grain by grain, carrying traces of distant systems in its soil for as long as physics allows. Traveller. The lesson here is one of patience. The universe rarely changes worlds through sudden force. More often it does so through the soft persistence of dust, light and time. Mars has absorbed its encounter with 3i Atlas not as disruption, but as quiet companionship, allowing the chemistry of another star to rest alongside its own ancient minerals. Nothing more was required, nothing more occurred. Tonight, the stars will keep their silence, and Mars, cradling the faint memory of an interstellar visitor in its sands, will continue its slow turning beneath them, steady, unhurried and open to whatever the cosmos may place upon it next. It's all right to not know how long that memory will linger, or what soft stories the dust will carry forward into the ages to come. In the long arc of planetary history, most changes unfold at a pace so slow there may as well be silence. But every so often, something interrupts that silence, a shift measured not in eons but in seasons, not in continents moving, but in molecules waking. The aftermath of Mars' encounter with Thruai Atlas lives entirely within that quieter category of change. Nothing dramatic reshapes its horizon, no new features dot its landscape, and yet beneath that steady red surface threads of new chemistry continue weaving themselves into the planet's long memory in ways subtle enough to overlook yet persistent enough to matter. Scientists monitoring the data weeks after the event found themselves returning again and again to the same charts, tracing the same gentle rises and dips in thermal readings, atmospheric fragments and dust-borne compounds. Hydrogen cyanide continued fading from the sky, but not quite at the rate their models predicted. Nickel grains remained visible in spectroscopic scans, moving patiently through layers of dust like tiny travellers searching for equilibrium. Everything followed the rules of physics, but with a softness that hinted at new interactions taking root. Nothing was stable in the rigid sense. Everything was settling, adjusting, finding its place again. Day by day, the planet's surface began reflecting these adjustments in ways that did not disturb its stillness. Slight variations in surface warmth appeared when nickel clusters concentrated in shallow drifts. Ultraviolet light striking those reflective grains created microclimates, pockets of warmth, no wider than the shadow of a pebble. In these places, carbon-based residues reacted with sunlight for an instant before cooling again at night. None of these reactions scaled upward into anything transformative, but they marked a change in the choreography of Martian dust, a new rhythm the planet accepted without resistance. The rovers, oblivious to the poetry of what they were witnessing, simply recorded their findings. Curiosity's sampling showed that the unusual metal distribution persisted. Maven's atmospheric logs displayed the gentle taper of cyanide drifting toward non-detectable levels. Orbiters tracking the planet's reflective properties noticed minor variations they attributed to dust movement, but quietly flagged for deeper review. This is how early discoveries often appear not as revelations, but as small inconsistencies that linger at the edges of measurement, waiting for someone to notice the pattern they form. Daylight on Mars continued its patient cycle, rising with a thin, dusty glow and settling into cold blue twilight. Through each cycle, the new chemistry behaved according to every model available, yet with its own quiet signature. Some regions held on to heat a little longer, others cooled slightly faster. Winds redistributed the dust as they always had, but their patterns carried traces of new materials mingling with old. Even these motions felt like part of the planet's natural evolution. Nothing hinted at danger, nothing suggested urgency. The changes seemed content to exist at the threshold of perception. Researchers debated whether the chemistry introduced by Thruai Atlas would persist for decades, or dissolve into the planet's broader mineral cycle within a few years. Both possibilities felt equally plausible. Mars has always been a planet defined by the slow patience of its geology. Dust rises, dust settles, minerals weather and reform across spans too long for human intuition to grasp. The interstellar materials would eventually join that cycle, whether by oxidation, burial, or simple dispersal. What mattered most to the scientists was not the duration of the trace chemicals, but what their behaviour revealed that even in its quietude, Mars remains receptive to the cosmos. Some of the more reflective nickel grains streamed across open plains guided by seasonal winds. These grains, bright under morning light, offered satellites, fleeting glints, small signals that served as markers of their slow migration. Over time, they would fragment further, breaking down into finer particles indistinguishable from native dust. In doing so, they would become another layer in the sediment of the planet's history, a record of an encounter that lasted mere hours but left a signature lasting far longer. Dreamer. This is the nature of cosmic contact. Not every meeting of worlds announces itself with spectacle. More often, the universe touches gently, leaving behind soft impressions that live quietly in the background of a planet's unfolding. Mars absorbed what arrived, responded through chemistry rather than catastrophe, and returned to its steady turning beneath the thin sky. Its silence was never broken, only reshaped slightly in ways that a patient observer can see if they look long enough. Even now, months later, the data shows that the dust left behind by the interstellar visitor continues to participate in small chemical dances. UV light interacts with carbon residues. Subsurface frost lends brief moisture to reactive grains before sublimating back into the air. Temperature swings create micro-reactions that last minutes before freezing again. Each process is tiny, barely measurable, yet each one contributes to the planet's ongoing dialogue with its new chemistry. There is comfort in this gentleness. Nothing here suggests instability or threat. What emerges instead is a portrait of a world capable of receiving the universe's fragments without being overwhelmed by them, a world ancient enough to incorporate the foreign into its own rhythms. For scientists, this offers a glimpse into how planets across the cosmos might evolve after brief encounters with drifting relics from distant stars. For the rest of us, it offers perspective. Not everything the universe touches becomes a disaster. Sometimes the encounter is quiet. Sometimes it simply leaves a memory. As Mars continues to orbit the Sun, carrying the faint trace of 3I Atlas across its dust, it reminds us that cosmic events don't end when the object moves on. Their echoes persist in small, delicate ways that reveal themselves slowly, as though the universe is whispering rather than declaring. It's all right if we don't yet understand the full meaning of what was left behind. Time will clarify what urgency never could. And in that time, Mars will keep turning steady and silent, honouring the encounter, not with transformation, but with patience. Traveller, if you're still here, then you followed this story all the way to its quiet edge. The place where data becomes reflection, and reflection becomes something softer than certainty. Mars is changing, yes, but so are we simply by watching it. Sometimes the universe rewrites a world, other times it rewrites the ones who dare to look closely enough. Tonight we trace the faint imprint of an interstellar visitor across a silent planet. But the truth is larger than Mars. It's the reminder that the cosmos is never finished with us. Every dust grain, every chemical spark, every misfit anomaly is a whisper from a place older than memory. A reminder that the line between what we build and what we awaken has always been thinner than we assume. There is humility in that, and wonder, and a kind of fragile gratitude that we get to witness even a fraction of it before it fades into the dark again. Whatever Mars becomes, whatever emerges in that red silence, the mystery will continue its slow unfolding with or without our measurements. So rest for now, let the questions drift. The universe will keep watch as it always has, and when you're ready to wander further into the quiet, another story will be waiting. Stay curious.